Hello everyone, welcome to another episode of our farming RPG tutorial series. So you might notice that after the player leaves the house, can't really interact with the land anymore. That's because he's floating in the air. So we need to give our player a little bit of gravity. So let's go over to our play controller script and let's have a new float. So this would be our gravity value, which is set to 9.81. And over in the move function, we need to give it a y velocity. But first, we need to know if the player is grounded. Luckily, the player controller has a built-in isGrounded function. Controller.isGrounded. And then we can just set the velocity to 0. Because as long as the player is on the ground, there shouldn't be any gravity acting on it. But if the player is not on the ground, gravity will start acting. It will be time.delta time multiplied by the gravity value. Now let's give it a test. As you can see, player now has gravity applied. But because gravity is constantly being applied, player is stuck in the walk animation because we're using the magnitude of the velocity. Let's get that fixed. Instead of velocity, we'll be using the direction value. Because the direction, the dir value, only records the player's input, whereas the velocity includes the gravity value. There. Okay, now that the player has gravity falls if he walks off the map. So we need to make sure that everything here is locked. Let's set some boundaries. They shouldn't be able to walk off the map now. Likewise over here, we have put up fences. Okay, that's it for the gravity side. Now let's finish up the loading system that we held off before. As you can see, right now in our Essentials prefab, we have this little button here that loads the save. But this is kind of incomplete because it doesn't work if you're in the player's farm. So let's remove this first. And to keep things simple, let's move the Essentials prefab over to PlayerHome. This will be where the player starts instead. Okay, now let's create a new title screen. Let title. Give it a nice little canvas. Now, I think it would be really nice if we dragged in the player prefab and then we had the player do something interesting. Put a title screen in front of the camera or something. But for now, we'll just be using a still image for the title's background. So let's drag this over here. Make this a sprite. Select image. Set this to the sprite. And then let's create 3 buttons. There. And now we'll add an empty game object to the scene. Call this main menu. This will be the game object that will primarily be handling all these buttons. And then create a new script for it. Create it in the UI folder. Call this main menu. Let's open it up. We'll be using Unity Engine.ui. And we'll need one function each for each of the buttons. And now we just have to assign each of them. So for the new game, continue, it's continue. Quit, it's quit. Now quitting is rather straightforward. It's just application.quit. So to load a new game, as mentioned before, we moved the Essentials prefab over to PlayerHome, because everything should start over in this room. Right, now let's improve on this space. Open paint.net. We're just going to take this texture, because if we were to just apply this material, the UVs are not mapped, and we want to use the tile texture. So let's just take this. Now we can just make a new material. Add the one that we just made and okay, we have some errors over here because we made this back when we assumed that the prefab would start at the farm. Now it doesn't, so we need to check if it's null, because there's no need to do any of these updates if there's nothing to update. So it should return. Yeah, the error should be gone. Let's disable the day-night cycle since it's indoors. So over in Scene Transition Manager, we'll declare an array of locations which are indoors. For now it's just the player's house, and make a function. The array has a function indoors.contains. I'm going to be using system.length. So this basically checks if it's in the array. If it's in the array, current location is in the array, that means it's indoors. And now over in Time Manager, where we have the day and night cycle controlled, we can disable the day and night cycle. So we need to set the sun transform to a consistent angle. So now let's put it to 40 degrees and we'll set this. We're currently in the player's house. Yep. The lighting will be consistently like this. And when it's not, it follows the day and night cycle. Okay, now we go back to our main menu. Save it. So to start a new game, all we need to do is load the scene. Don't forget to put title over in the build. What happened to our event system? We might have accidentally deleted it. Yep, and this starts our new game. And everything is brand new. It's well and good. Now we need to load the game. At first, we need to check if there is anything to load to begin with. Because if there's nothing to load, the player shouldn't be able to click continue because there's nothing to continue. So over in Save Manager, we need to create a function that checks if there is a save file to begin with. So let's create a new function. Save. We just need to check if the file exists. If the file path, that's it. And now we need to add a new button, load game button. Assign this here. And then over in the start function, I'm using the interactable value. So it's interactable if there is a save. And if there is no save, it shouldn't be interactable. And there is a save, that's why it's still interactable. But if I delete the saves over here, play the game, it is disabled. That's according to it says it should be. So now how do we load the game? So in new game, all we do is load the player home scene. And in load game, it does the same thing, but it does an extra step, which is to load the save data. As we see over here in game state manager, under load save, so it loads the player's home, and then it does all these things. Now we won't be needing this anymore because we'll be loading it over from the main menu. So we'll load it up here first, and then we call it here. And since all our singletons, now the next problem would be game state manager and every other singleton that we have is going to be connected to our essentials prefab. But we cannot access it until we have first loaded the player home scene. So to load the scene, we can't just directly call a function. We need to use a coroutine to wait for the scene to load first, and then we find the game state manager, and then we call this function. So let's create a coroutine. We're gonna asynchronously load the game so that we can track its progress. So in future, if you want to create a loading screen, we can also play around with the values. Take in the location and convert it to string. Then we can wait for it to load using the isDone, and then we wait. And then once the scene is loaded, it'll be here, scene loaded. Okay, let's do this first on new game. We're gonna start coroutine, load game sync. Do a sanity check first, debug.log, loading. And once it's done loading, shows loading, but it doesn't say loaded. This is because once the scene is loaded, this class is going to be destroyed, and then it cannot do anything else. So we need to don't destroy and load this game object first. After the scene is loaded, we can destroy. Now when we test it out, so it loads and then it's loaded. So that I can execute this part of the code. So what we need next is an action, a callback. We want it to wait until the first frame, because we want all the start functions from all the singletons to be called first before anything is loaded, else everything will conflict, right? So we load, return, wait for end of frame using system, and then after first frame is loaded, we can call the first frame load. Okay, so we wait until the first frame is loaded. This game state manager has to work with the time, register itself, in the time manager, all the start functions. Okay, now that the first frame is loaded, we can on first frame load dot invoke. Now to work on the action. So let's create a new function, void load game. Need to get the game state manager dot instance. So if it's null, it's just going to return, and it's going to throw an error. but if it can, it's going to load and save. Now we can just add the load game over here. And let's save this. Now you see there's a continue game button that is interactable. We click continue, it loads our game for us. And now when we go outside, you see that everything is just as we made it. So now the load game function works. So we can move on to our next task, which is to generate the obstacles. Let's go over to farm. Right now, the player has no problems just planting his seeds and cultivating the land and all that. But usually, in Harvest Moon games, there will be obstacles that spawn that the player has to clear first before he can do anything. So, let's go to Important Assets. Let's look for our rocks. So there will be 3 types of obstacles. A tree stump, so these are the 3 types of obstacles that the player have to clear. Let's make the rocks a little larger. Make it a bit taller so the player can climb on top of it. Okay, and we'll create a new folder. It's obstacles. These are all these. Take all these. Make sure the position up to 0. And now we just have to spawn them in our land prefab. Let's go to our land class. The logic is going to follow the same thing as what we did with land status. So get a new enum, farm obstacle status. Then we need a game object, just like the soil, farm, and water, rock, wood, and grass. And when we instantiate each of these, we need to track it in a variable. Now, just like switch land status, we will need a function that will switch between the obstacle status. Same logic as this, so we need a switch case for each. So for each of them, we're just going to instantiate. So for rock, it's going to be rock. Wood is the same with wood, and for wood, it's wood prefab. Weed, it's weed prefab. And when it's set to none, destroy the obstacles. Now, if we just instantiated them, it's going to end up like the crops. It's going to be stuck inside. So we have to move it. But extending, it has to exist. Okay, let's see this in action. So let's do a little sanity check first. Assign all weeds, wood. Now let's set everything to turn to rock. Just for testing purposes, we'll put essentials here. Now everything is rock, looking good. Now let's make everything wood. Looking good. Set everything weeds. So everything is working properly as it should. Next is interacting with them. We look at our tools. We have our axe to cut down wood. We have our pickaxe to cut down stone. And our shovel to clear all plant materials, and that includes our weeds. So let's go over to our interact function over here. Little shovel, now we can just do this for every other obstacle. Now, don't forget, our player should not be able to plant if there is obstacles. Cannot just carry on as usual. Let's test it out. For now, let's set it to wood. Now the player should not be able to plant his seeds. Here he chops it up. Yep, he needs an axe to chop it up. Can't chop up wood with a pickaxe, only with an axe. Now let's see the rocks. Player is able to remove the rocks with his pickaxe. The weeds. Player is able to remove them with his shovel. So all of them are working just fine. Now we want to save and load the state of each of the obstacles, because it makes sense, right? Like if the player clears a bit of the obstacles, his progress should be saved and everything should be as he left it. So let's go to land save state. We'll just add a obstacle status, and then I'm gonna throw up an error because over in land manager, and it's during the constructor, we also need the obstacle status. And how do we know the obstacle status? We need a variable. We need to take it as a parameter. Now it's gonna throw up more errors because the one that calls this also needs to take in the obstacle status parameter. Switch land status in the land class. So now every time the land status switches, it updates the land state change. But the land state now changes in another function as well, and that is our set obstacle status. Let's just put this here as well. No errors. Okay. So now let's go back to the load land data function. Should take in the obstacle status. And the logic is about the same. Just like how it called switch land status without calling this, we also need to do the same thing here. So let's copy everything here, leaving behind the on-land state change, and paste it. Okay, obstacle status to switch, so we don't get confused. So we change this and change this. Okay, now in import land data, over in land manager, we have to land data to load, and there shouldn't be any more errors. Okay, now the saving and loading of our obstacles are done. We just need to spawn our obstacles. So over in the farming folder, let's create a new script for this obstacle generator. Now in generating obstacles, we want to control how much of are we going to fill this, if it's going to fill every block or just a certain percentage. So be between 1 to 100%. And what we want is it's going to pick at random which plot of land will have obstacles. So with that, what we want is take in a list of all these, shuffle them randomly, and we'll pick the first X amount of plots, and then we'll prop up an obstacle. So we'll need a shuffle function, and to make things optimal, we'll only be shuffling the index, not the land list directly. There are a lot of ways to shuffle this. What I've come up with is this. So we're going to randomize the indexes, and then we're going to iterate through the count of the total. So for example, there are 432 plots of land. It's going to iterate through each of them. Let's say the value is 0. It's going to assign a random index to it, and then build it up from there. We're going to do a for loop. Random between 0 and, because as the list is expanding, let's say the list at its first value 0, it's going to between 0 and 5 plus 1, since the max value is exclusive. So for example, let's say at the second value I is 1, and then it's going to pick between 0 and 1, and then it slots it in. I'm going to use the insert function. For example, the thing starts at 0, and then this thing is between 0 and 1 exclusive, and then it gets 0. The 0 is put at index 0. Then now I have 1, and now it's between 0 and 1. And then if it randomly gets 0, you slot in here, and 0 is pushed back. And then the whole cycle repeats. So now if I is 2, then it'll be between 0 and 3 exclusive, and then if it picks 2, it'll be slot in here. And then the thing gets bigger and bigger and bigger. And then it'll basically shuffle like that. And then it'll go all the way to 432. Okay, so now that we have a list of indexes that will be shuffled in a random order, let's make the little function to generate the obstacles for us. Right, land manager, feed it the land plots, and then we'll calculate. Going to be percentage fill divided by 100 times land plots dot. Now since this is an integer, it will return 0, and 0 times this will always be 0. So we need to convert this to a float, and then just round it off. The shuffle land indexes function, land plots. And then we'll use this plots to fill value, create a for loop. Gonna be the shuffled list. The I index of the shuffled list will be the index of the land to fill with the obstacle. Then we'll randomize the obstacle spawn. Gonna be a random range. Gonna be between 1 to 4. Now you see, we want it to either be rock, wood, or weeds. So in random range, the minimum is inclusive, so it's going to be rock, and exclusive is 4. So the maximum value it can return is 3. So just exactly as we want it, rock, wood, and weeds. Now, just an integer, we just need to cast it to our enum value. Okay. We'll take this index and then set obstacle status. The status we generated. Okay, and that's it for generating the obstacles. Now let's go to the land manager. We can put it over here on enable, but we only want this shuffling and generating of the obstacles to be on a fresh save file. Else there won't be any continuity. Every time you load a game, there'll be random obstacles generated and it's just gonna overwrite your farm, which is not a very nice thing. So we're gonna be over here in the load farm data coroutine. It's gonna check if there's any farm data, anything to load at all. Not, that means it's a new game. And what we want is obstacles to be here. Let's say we want 50%, 70%, 60% filled. Wire component, so we don't throw an error. There you see everything's generated. About 60% of the land is filled with obstacles. You can always tweak it around. It's just 15% to look like this. I think 40% is a nice number. Okay, let's test everything out. If I start a new game, I see that my farm is overrun with obstacles. So I want to clear it out. I'm going to clear out a nice little space here. You see I have a nice little space here. I can cultivate my land. I'm just gonna go and save. This morning everything is fine and dandy. If I go back to the title and load my game, come out, the obstacles are exactly as they are. My progress is about the same. There you have it. That's it for this tutorial. Hope you enjoyed it, and we'll see you next time.